We want to take the rectangular coordinates 2, 2 and convert them to polar coordinates. So we're going to use the definition that r is equal to the square root of x squared plus y squared. So r, in this case, is going to be 2 squared plus 2 squared, the square root of that, which is the square root of 8, which is 2 square roots of 2. And then, to find theta, the tangent of theta is equal to y over x. So the tangent of theta is going to be equal to 2 over 2, which is 1. So either using your unit circle, or we can use a special right triangle. We have an angle where opposite over adjacent is equal to 1. And so that happens whenever theta is equal to 45 degrees, or in radians, pi over 4. So our polar coordinates for 2, 2 will be 2 square roots of 2 pi over 4. Now we want to take 2, negative 2, and so we're going to do a similar process. Notice that we're going to get the exact same thing for r, because r will be the square root of 2 squared plus negative 2 squared, which is still the square root of 8, which is 2 square roots of 2. And when we find the tangent of theta, it's still going to be y over x. And I'm going to ignore the negative for a moment just to find my reference angle. And so the tangent of theta will equal 1, which means that I will have a reference angle that is equal to 45 degrees, or pi over 4, just like we did on part A. The difference is, when we're looking at the coordinates 2, negative 2, that means that we are in quadrant 4. And so if we're in quadrant 4, and we have a reference angle of pi over 4, then our coordinate for theta will equal 2 pi minus pi over 4, which, if we get a common denominator and subtract, will be 7 pi over 4. So the polar coordinates for 2, negative 2 are 2 square roots of 2, 7 pi over 4.